So these are the angle sum formulas, angle difference formulas, and then on the other side, we have the same angle sum formulas, but now we're going to modify them or re-express them slightly. So we still have sine of alpha plus beta is equal to sine of alpha times cosine beta plus cosine of alpha times sine of beta. But now I'm going to replace each angle, alpha and beta, with the same angle. You could call them both alpha or A. I called them both theta. So I'm just replacing every alpha with theta and every beta with theta. And so then sine of theta plus theta, well, theta plus theta is just double theta or 2 theta. And sine of theta plus theta using the double angle formula, using the angle sum formula is sine of theta times cosine theta plus cosine theta times sine of theta. But these are the same. Right? Sine times cosine is the same as cosine times sine. So we can just say, well, I have 2 of these. Sine times cosine plus another sine times cosine is 2 sine theta times cosine theta. And this is the double angle formula for sine. Sine of 2 theta is equal to 2 times sine of theta times cosine theta. I want you to be really careful about this because I've definitely seen people accidentally write that sine of 2 theta is just equal to 2 sine theta. That is not true. Sine of 2 theta is equal to 2 times sine theta times cosine theta. In the same way, we can find a double angle formula for cosine. We know that cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And then if we replace each angle with the same angle theta, cosine of theta plus theta is equal to cosine theta times cosine theta minus sine theta times sine theta. So cosine of 2 theta is equal to cosine times cosine, which is cosine squared of theta, minus sine times sine, which is sine squared of theta. So the version of the double angle formula I prefer to remember for cosine of 2 theta is that cosine 2 theta is equal to cosine squared theta minus sine squared theta. The reason I say the version I prefer is because there are a couple other versions that I will show you shortly here for cosine of 2 theta that are a little bit different. But I think this, for me, this one is the most natural one to remember because it comes straight from the angle sum formula. I also want to point out, just because I've definitely seen people make this mistake before, cosine of 2 theta is not generally equal to 1. Sometimes people make the mistake of thinking that this is cosine squared theta plus sine squared theta. That is equal to 1. But this is cosine squared theta minus sine squared theta, which is definitely not usually equal to 1. So these are 2 of the formulas we're going to be working with today. And we're just, so here's what I'll say about the double angle formulas. We don't really use them to evaluate the trig functions of any new angles. Right? For the angle sum formulas that we were doing yesterday, we definitely use those to evaluate angles like cosine of pi over 12 or sine of 165 degrees or anything that was something kind of like that was a sum of angles we knew. This, not so much. There aren't really any new angles, new special angles that are double any of the old special angles. For example, it's really cool if it had been like a whole new side, but I've done some cool editing magic that I don't think you can really do live. If I had like an extra person writing stuff on the other side, that'd be kind of tricky. So for example, we could use the double angle formula to see something is true. I could see that sine of 2 times 45 degrees is equal to 2 times sine of 45 degrees times cosine of 45 degrees. This is true. 2 times 45 degrees is 90 degrees. And sine of 90 degrees using the unit circle, I'm up here at 90 degrees, or pi over 2 radians, right? Either way you like to slice it. Well, usually we slice it with a radian, not with a slicing. My analogy stopped working. Anyway, sine of 90 is 1. And sine of 45 degrees is root 2 over 2. Cosine of 45 degrees is also root 2 over 2. And you can cancel this 2 here with one of the 2's there. And then root 2 times root 2 is 2. And we still have a 2 in the denominator. And yep, that checks out. But you would never use the double angle formula really to find sine of 90 degrees by saying it's sine of 2 times 45 degrees. You would just use the unit circle and be like, oh yeah, I know that sine of 90 degrees is 1. Which I think just about all of you did. I was just reading that problem on the homework, and I think everybody got sine of 90 equal to 1, right? So good job. I will try to get that homework graded completely by the end of today so that you can all see the feedback on there. A more standard kind of question that you might ask involving the double angle formula is one like this. This is going to be similar to some stuff we did at the end of the class yesterday, where I tell you that cosine is equal to something, I give you kind of a quadrant, and then we try to figure out some other stuff. So let's say we know that cosine of an angle, theta, is equal to the square root of 7 over 4. And theta, I'm just going to tell you, is in quadrant 4. There's a couple other ways I could have said this. I could have instead said sine of theta is negative, or I could have said tangent of theta is negative. Either one of those pieces of information, coupled with the fact that cosine is positive, would have to mean we were in quadrant 4. Right? Because quadrant 4 is the only quadrant where cosine is positive and either sine or both sine and tangent are negative. So the first thing we want to find is, what do I got in my notes here? Sine of 2 theta. When I'm asked to find sine of 2 theta or cosine of 2 theta, the first thing I'm always going to do every time is just write down the formula. It's 2 times sine of theta times cosine of theta. And then I'm going to try and start filling stuff in. I don't know what sine of theta is yet, but I do know that cosine of theta was given to me. It's the square root of 7 over 4. What do I need to do to be able to figure out what sine of theta is? Draw my favorite shape. Maybe my favorite shape, I don't know. Certainly my favorite shape in trigonometry, right? Trigonometry probably starts with the letter TRI for a reason, because there's a lot of freaking triangles in trigonometry. We need a triangle. We need a triangle where the adjacent side is root 7 and the hypotenuse is 4, because cosine of an angle is the adjacent over the hypotenuse. And then we're going to find this third side, like we do every time in a right triangle, by using the Pythagorean theorem. Square root of 7 squared plus x squared equals 4 squared. 7 plus x squared equals 16. X squared equals 16 minus 7 is 9. X equals 3. I'm not worried about the fact that it might be positive or negative. When I'm just drawing a triangle, I'm just going to draw the triangle with all positive sides. Okay, so then sine of theta is the opposite over the hypotenuse, which is going to be 3 over 4. But I'm in quadrant 4, so I know sine of theta is actually negative. And then we would multiply it out. I'm going to say this is 2 over 1. So I have 2 times negative 3 times root 7 is negative 6 root 7. All over 1 times 4 is 16. And then I can cancel a factor of a 2. So this I can factor out of 2, and this I can factor out of 2. You can get negative 3 root 7 all over 8. And then we can find cosine of 2 theta. Cosine of 2 theta is equal to, again, whenever I'm asked to find something of 2 theta, I'm just going to throw down the formula. It's cosine it's not cosine squared of 2 theta. It's cosine squared of theta minus sine squared of theta. One thing to be careful of, and I've seen this too many times, be careful that this, if you're writing cosine squared, that this 2 doesn't somehow migrate down to be next to the theta. I've definitely seen cosine squared thetas magically transform into cosine of 2 thetas on accident many, many times. So just be careful. If it's 2 times theta, that's different than being cosine squared of theta. So then cosine of theta was root 7 over 4. So it's going to be root 7 over 4 quantity squared. And then sine of theta we found to be negative 3/4, so it's minus negative 3/4 squared. Simplifying that, square root of 7 squared is 7, 4 squared is 16, minus negative 3 squared is 9, 4 squared is 16. And then erasing some of this work over here so I have a little more room. 7/16 minus 9/16 is negative 2/16, which reduces to negative 1/8. One of the nice things about any problem like this, where you're asked to find like sine of a new angle and cosine of a new angle, is they should almost always be, if they're fractions, which they almost are always fractions, they should almost always have the same denominator. That's just a thing that is always true. So if you see things that have the same denominator or reduced to have the same denominator, then you're probably on the right track. Last question, which I know I'm kind of out of room for. What quadrant, in fact, so I would like you guys to type in the chat, based on the fact that sine of 2 theta is negative and cosine of 2 theta is also negative, what quadrant does 2 theta have to be in? 1, 2, 3, or 4? Take a long sip of water. Yeah, those of you that are answering, you were definitely correct. It is quadrant 3. Because that's the only quadrant where both sine and cosine are negative. So we'll do 1 or 2 more like this, and then we'll move on to the half angle formula, which really has a lot to do with the double angle formula. I think the light in here could be better. Maybe that's a little better. Okay. You guys see, as long as you can see the board, it doesn't really matter, right? Okay. So you can see the board and hear my voice. Maybe that seems like all that's really important in this room. Okay. Let's put pens here. So another example, I'm gonna do this one slightly differently. So let's say we have sine of theta equal to 1/6, and theta is in quadrant 2. So we know, and let's say we're starting with, so we're going to find the same things. So we're going to be asked to find cosine of 2 theta and sine of 2 theta, and then the quadrant. But I do want to show you a trick that only works for cosine, doesn't work for sine. So if you're ever asked to find really just cosine of 2 theta, you don't actually have to draw the triangle. Although I'm still going to draw the triangle anyway. If I'm finding cosine of 2 theta, I'm going to write out the formula as cosine squared theta minus sine squared theta. But then I'm going to remember a trig identity. I know that cosine squared theta is equal to 1 minus sine squared theta, right? Or really, I'm remembering that sine squared theta plus cosine squared theta equals 1. So that cosine squared theta is 1 minus sine squared theta. And normally I wouldn't replace this with this, but here it actually kind of makes sense. I can replace this with 1 minus sine squared to get 1 minus sine squared theta minus sine squared theta, which is equal to 1 minus 2 sine squared theta. So it's kind of nice that you can actually find cosine of 2 theta if you know sine or cosine without having to draw the triangle. You could still totally draw the triangle and it would work out just fine too. But here I could do it as 1 minus 2 times sine of theta is 1/6, so it's going to be 1/6 squared. So that's going to end up being 1 minus 2 times 1/36. 2 times 1/36 is 1/18. And 1 minus 1/18, or 18/18 minus 1/18 is 17/18. We also could have drawn triangle. The thing is, as much as we would like that to work for sine of 2 theta, it doesn't work for sine of 2 theta. We have to draw the triangle for sine of 2 theta. So for sine of 2 theta, first of all, it's going to be 2 sine theta times cosine theta. And then that's going to be 2 times 1/6 times, I don't know what cosine of theta is. I know what cosine of 2 theta is. That doesn't tell me what cosine of theta is ever. I need to go back and draw the triangle. I'm going to draw the triangle. I'm going to draw right here. There's my right triangle. And sine of theta is opposite over hypotenuse, so that's 1/6. And the third side here, x squared plus 1 squared equals 6 squared. So x squared equals 36 minus 1 is 35. So x equals the square root of 35. So cosine of theta is adjacent over hypotenuse, which is going to be the square root of 35/6, except we're in quadrant 2, where cosine is negative, so it's negative square root of 35/6. And then we multiply it out. So I get negative overall, right? So negative times a positive times a positive. I get negative 2 root 35 all over 36. That's what 6 times 6 is, 36. And then you can cancel a factor of a 2. So that's an 18 on the bottom. So you get negative root 35 all over 18. And that's what sine of 2 theta is equal to. 2 things. First thing, what quadrant is 2 theta in? If cosine is positive and sine is negative. Two theta is definitely in, thank you, yes, someone said quadrant 4, I appreciate it. The other thing I wanted to mention is just more of a, I don't know. It's really important when you're writing sine of 2 theta is equal to negative root 35 over 18 or whatever, that you actually write the angle in there. If you just write sine is equal to negative root 35 over 18, it's just not quite right, right? There need a sine of what? Do you mean sine of theta? Do you mean sine of 2 theta? Do you mean sine of 45 degrees? So I really want to encourage and reinforce the idea of when you're writing sine or cosine or any trig function, there needs to be some angle in there. Either an angle like theta or an angle like pi over 6, right? There needs to be some angle that's going inside the argument of the trigonometric function. So
I have a quick question.
Go ahead, yeah.
Where did you get the 18 from?
Which 18? This one?
In the denominator? Yeah, that one.
So here I had, so I multiplied out the top. So really, just say this is 2 over 1. So I multiplied out the top and I got 2 times 1 times negative root 35, which became negative 2 root 35. And I multiplied out the bottom and I got 1 times 6 times 6, which was 36. But then 2 and 36 both have a common factor of 2, so I divided that out. And 2 divided by 2 is just 1, which I didn't write. Excuse me. And 36 divided by 2 is 18.
Thank you.
You're welcome, of course. And so, and typically it is a common practice. Like if you're writing an answer, the expectation is usually that you do simplify all fractions by reducing them as much as possible. So like if you're writing an answer like, 2 root 2 over 2, because you found like secant of pi over 4, you should definitely cancel those 2's and just write your answer as root 2. All right. Let's see, did I have another one of these or not? I think I just did. No, okay, cool. So we're gonna take a closer look at this. That cosine of 2 theta is equal to 1 minus 2 sine squared theta. Oh, that was fast. So in fact, there are 2 alternate versions of the double angle formula for cosine. I will also stop and say that is about all we really do using the double angle formula. Like if someone's asked you to do a double angle formula problem, it's usually going to be something kind of like that, where they give you sine or cosine and then ask you to find sine of 2 theta and or cosine of 2 theta and possibly the quadrant. So here's our double angle formula for cosine. It's cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And that is James's favorite version of the formula. I couldn't tell you why it's my favorite. It's just the one I like the most. But we just saw that you can replace cosine squared theta with 1 minus sine squared theta, right? Because we have, again, come on, pens. We know that cosine squared theta plus sine squared theta equals 1. So we can replace cosine squared with 1 minus sine squared, which we just did, and get cosine of 2 theta equal to 1 minus sine squared theta minus sine squared theta. Right? Specifically, cosine squared theta is becoming the 1 minus sine squared theta. And then that's 1 minus sine squared, which is 1 minus 2 sine squared. Whoop. Don't let your 2's transform into squares. I almost did it. It's almost terrible. So we get 1 minus 2 sine squared theta. And then the other version, you can replace the sine squared with, well, if I solve for sine squared, it's 1 minus cosine squared. So I can say that cosine of 2 theta is equal to cosine squared theta minus sine squared, which is 1 minus cosine squared. I can distribute the minus sign and get cosine squared theta minus 1 minus is plus cosine squared theta. And then cosine squared theta plus another cosine squared theta is 2 cosine squared theta. So I can say that cosine of 2 theta is equal to 2 cosine squared theta minus 1. So each of these are perfectly valid formulas. I do not need for you to memorize them. I don't think you need to memorize them. Most of the reason we are talking about them is because they then allow us to find the half angle formulas. So these are formulas that may or may not come up in your mathematical future. They probably won't come up. No, that's, I mean, no, maybe, kind of. I don't know. These ones are not the most important ones. So I would, if I had to remember one formula, I'd remember this one, and then just remember how to get to these two if I had to. But now we're going to use these to derive what are the half angle formulas. And those are of some moderate importance. Sorry, I'm trying to keep track of all my papers here. Got my scratch paper. Okay. So, yeah, I'm going to use that formula to derive a half angle formula. And so the reason they're called half angle formulas, at least the way I think of it, is because they allow you to evaluate angles that are half the measure of what we used to be able to. I'll show you what I mean by first deriving the formula. So here's one of the formulas. So we had 2 cosines, whoops, it's okay. I'm writing it the opposite way as I did before. So right, our formula, one of our alternate formulas was cosine of 2 theta is equal to 2 times cosine squared theta minus 1. And now what we're going to do is we're going to isolate cosine theta, or solve for cosine of theta. So I'm going to add 1 to both sides. You can show my work if you want. I'm going to add 1 to both sides and say that 2 cosine squared theta is equal to 1 plus cosine of 2 theta. And although it doesn't really matter which way you write, where you write the 1, there's kind of a standard way of writing these formulas, so I am kind of writing it in what's going to become the standard way. I'm going to divide both sides by 2. So dividing by 2 here just cancels out. So you get cosine squared theta. Over here, without parentheses, I get all of this divided by 2. And then finally we take the square root. Now, here's something important to remember. If cosine squared of theta is equal to 1 plus cosine 2 theta over 2, cosine could be positive or negative, but this is always going to be positive, right? 1 plus cosine 2 theta over 2, always going to be, I should say, non-negative, really. But the thing is, right, cosine of an angle could be positive or negative. So when we take the square root of both sides, we have to say that cosine of theta is equal to plus or minus the square root of 1 plus cosine of 2 theta all over 2. But here's the thing. Cosine of theta isn't positive and negative. It's one or the other. It depends completely on what quadrant theta is in. So what I want to remind you of, and I'll remind you every time, is that this sign here depends on the quadrant of theta. So the sign depends on the quadrant theta is in. So if theta is in quadrant 2, it's going to be negative because cosine of theta is negative when theta is in quadrant 2. If theta is in quadrant 4, it's going to be positive because if an angle is in quadrant 4, cosine is positive. All right, now we're going to derive the other formula, and what we're going to see is they're almost virtually the same, which is kind of cool. Makes it easier to remember them, I think. I think we can fit it in over there. Yeah, we got enough time. So I'm going to use the other formula, which I'll remind you. The other formula is cosine 2 theta equals 1 minus 2 sine squared theta. So cosine of 2 theta equals 1 minus 2 sine squared theta. And just like here I solved for cosine of theta, here I'm going to solve for sine of theta. So first things first, I'm going to add 2 sine squared theta to both sides. And I'm also going to subtract cosine of 2 theta from both sides. So they end up with just 2 sine squared theta on the left, because that cancels with that. And I'm going to equal it to, let's see, sorry. I'm going to have 1 minus cosine of 2 theta, because this and this cancel out. So I'm trying not to get red all over my black pen. Then we're going to do the same steps. We're going to divide by 2. So sine squared of theta is equal to 1 minus cosine of 2 theta all over 2. And then we're going to square root both sides. So the sine of theta is equal to plus or minus the square root of 1 minus cosine of 2 theta all over 2. Sorry, I didn't write that very nicely. Let me write that a little bit nicer. Sine of theta is equal to plus or minus the square root of 1 minus cosine of 2 theta all over 2. And just like over here, we'll also say the sign here depends on the quadrant that theta is in. But here it's the sine function, so if theta was in quadrant 2, it'd be positive. And if theta was in quadrant 3 or 4, it'd be negative. Okay, so those are the half angle formulas. And we can use them to evaluate some angles that we know that we couldn't before. So let me actually, I don't know, we'll start there. So there's really only one, oh, I should say that too. Sorry, there's a couple of things I'm meaning to say. Where'd you go, papers? Yeah, okay, we got you, cool. Oops, sorry. So there's really only one type of angle that we're going to use the half angle formula for. And it is an angle that is, so, I should just write that. So we use the half angle formulas to evaluate sine or cosine of angles that are half, hence the name, of an angle whose reference angle is pi over 4, or 45 degrees. Those are typically the types of angles we use this formula for. Now you could use it for anything really, but I'll show you if I have enough time how it's not the best thing to do if you don't have to. So we're going to use this to evaluate, say, sine of 22.5 degrees, which is half of 45 degrees. Okay, so I'm going to look at the formula. The formula says sine of an angle is plus or minus the square root of 1 minus cosine of 2 times that angle over 2. So let me show you. That's going to be, I like to write the plus or minus the first step and then show the person doing the grading what I chose. The square root of 1 minus cosine of 2 times my angle. So 2 times 22.5 degrees. All over 2. Oh, my lights just flickered. Hopefully I don't lose power. That would be terrible. So then, a couple things. What quadrant is this angle in? 22.5 degrees is definitely in quadrant 1. So from quadrant 1, we know sine, we know all trig functions really, but sine specifically is positive in quadrant 1. Now, the whole reason this works is because we're not actually going to try to figure out what sine of 22.5 degrees is by just evaluating it. We're going to be like, oh, look, over here, I've got cosine of 2 times 22.5 degrees, which is cosine of 45 degrees. So that's the whole reason this is the half angle formula, because you use the half angle formula to evaluate angles that you can find that are half of angles that you actually know how to find. Right? I don't know how to deal with this, but I know how to deal with the angle that's twice it. So I get positive, I should give myself a little more room. Positive square root of 1 minus cosine of 45 degrees all over 2. That's all inside the radical. And then that's going to be, I'm gonna not write the positive every time. You don't have to write the positive. You have to, if there's a negative, you have to write the negative every time. So I'm going to write 1 minus cosine of 45 degrees is root 2 over 2 all over 2. And the thing about this is it's actually not hard to calculate this, but it is a little bit of work. It's like 2 or 3 steps to actually simplify this to the right level. So here's how the simplification works. I don't want fractions in fractions. So I'm going to multiply this by 2 over 2 in the radical. So on the bottom, 2 times 2 is 4. On the top, I distribute. 2 times 1 is 2. And 2 times root 2 over 2, the 2's cancel, and I get minus root 2. There is one more step, which I'm going to show in 2 steps. When you have a square root of a fraction, you can write it as the square root of the top, as long as they're both positive, over the square root of the bottom. But what's the square root of 4? Nobody gave me an answer, but I know you all know it's 2. And there's our final answer. It's root 2, it's the square root of 2 minus the square root of 2 all over 2. This 2 in the denominator is not in the radical. This 4 in the denominator was. So it's kind of a lot of simplifying, I feel like, but it's kind of necessary. So I do expect you to write your answers like this. Sorry. The good news is that just like the angle sum problems, where all the answers were like plus or minus root 6, plus or minus root 2 all over 4, all of these half angle answers are going to look like plus or minus radical of 2 plus or minus root 2 all over 2. They're all going to look exactly like this, just with different plus or minuses. So at least they're all going to look the same. That's kind of good, right? We can kind of be happy about that, maybe a little. All right, so we did 1 with degrees. Let's do 1 or 2 with radians. So radians, it basically breaks down to, I know my angles that have pi over 4 as a reference angle have 4 as a denominator. And being half of that means I'm going to have 8 as a denominator. Oh yeah, and I'll say, there's some people like to do this a weirder way. I probably shouldn't even say it. Anyway. So let's see, what do we got here? I want to find cosine of 3 pi over 8. So, excuse me, the blank over 8, the whatever pi, the n pi over 8, that's the clue that we need the half angle formula. Just like yesterday, if we had something pi over 12, that was the clue that we needed the angle sum or the angle difference formula. So here, it's going to be plus or minus the square root of 1. So, fun fact, when it's sine, you start off with a minus here. And maybe that changes if this angle is actually positive, if this trig function is positive. But for sine, it's always, the formula is 1 minus cosine of 2 theta inside the root. For cosine, it's virtually the same except it's plus. So it's 1 plus cosine of 2 times your angle all over 2. So it's cosine of 2 times 3 pi over 8. Okay? So first things first, is it positive or negative? What quadrant is our angle in? We can dance.
The first quadrant.
Thank you, yes. I can stop now. Okay, good. Yeah, quadrant 1, which means we're again positive. So this is going to be positive square root of 1 plus cosine of 2 times 3 pi over 8 is 3 pi over 4, right? All of these, if it's something pi over 8 times 2, it's just going to reduce to the same something pi over 4. You can also actually write, you can say 2 times 3 pi over 8, or you can multiply it out and get 6 pi over 8 and then reduce to 3 pi over 4. I don't think you really need to show that work unless you absolutely want to. Okay, 3 pi over 4 is in quadrant 2. So cosine of 3 pi over 4 is going to be negative root 2 over 2. So it's positive square root of 1 plus negative root 2 over 2 all over 2. All right, and now we go through the same couple steps to simplify it. In the inside, we multiply by 2 over 2. So we get positive square root of 2 times 1 is 2. 2 times root 2 over 2, the 2's cancel, and you just get minus root 2, right? Because it's plus a minus, so it's minus root 2. And then the bottom is 4. And then I think you can skip the intermediate step here and go straight to just saying, oh, well, the square root of 4 is 2, no longer in the radical, and the top is just the square root of 2 minus the square root of 2. But if you want, you can show the intermediate step where you break it up into 2 radicals and you say, oh, it's the square root of the top stuff over the square root of the bottom stuff. But I really, really, really think it's fine to skip this step. If you want.
Wait, is that the square root of 3?
Where?
2 minus the...
I should say really, no, there's no 3's at all. They're all 2's.
Oh, wait, never mind.
Yeah, it's the square root of 2 minus root 2 all over 4. And then it's the square root of 2 minus root 2 all over the square root of 4. And then it's the square root of 2 minus root 2 all over 2. Yes. Sorry, to answer the chat question. Yes, Natalie, you are certainly welcome to change it to degrees. I should also point out, so just to kind of reiterate what I was saying before, we should definitely say that our answer is cosine of 3 pi over 8 equal to radical 2 minus root 2 all over 2. It's not okay to say that just cosine is equal to radical 2 minus root 2 all over 2, right? You need the angle. Sorry, there was the beginning of a question.
Oh yeah, I had a question. So after we multiply like the top and the bottom by 2, why do we have to square up the top and the bottom?
Because it's simpler. Because basically because 4 is a square number, right? If this was like something else in the bottom, like we happen to get a 7 or something, we would just leave it like this. But since 4 has a nice square root, right? The square root of 4 is 2. It kind of is it's our job to make it a little bit simpler. That's the best answer I've got for that question. Okay. Yes, we have time for one more, which is all I have. I do want to say one thing, and so this is how I've always preferred to do this formula, because I think it makes the most sense to do it this way. But some people like to write it slightly differently. So you are certainly, I would encourage you to do it the way we're doing, right? Where we say cosine of theta is equal to plus or minus the square root of 1 plus cosine of 2 theta all over 2. And then just whatever the angle is, put that angle in for theta. You put that angle in for theta here, and then you multiply the angle by 2 before you actually have to take cosine of it. Some people like to do a different thing where they say cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine of x all over 2. To me, I find this confusing, right? So for example, if I was going to find, say, I'm not going to do this one, if I was going to find the cosine of, well, in fact, the same problem as before, 3 pi over 8, it would be weird, but I would say, well, that's cosine of 3 pi over 4 divided by 2. So I can use this formula, and then my x is 3 pi over 4. And so then that's what's ending up over there. I really don't like doing it that way. I think it's kind of bizarre. But if that is what you like and it works better for you, you should do it that way, right? I'm definitely a fan of you should do it the way that works the best for you, as long as it's correct. Okay, so one more, and then we'll be done for the day. So let's do cosine of 11 pi over 8. All right, so that's going to be plus or minus the square root of 1 plus cosine. What angle should be going in there? It's probably a bit much to type. If someone wanted to tell me, that'd be lovely. Say it again.
11 pi over 8.
You're mostly right. So I would say it's going to be, and I assume you meant, right, it's going in for theta. It's 2 times 11 pi over 8. And then what does that simplify to? It can be the same person or a different person. Okay, so like we're almost out of time, so if we just wait, he'll have to say it himself. Well, you're right, I will. It's 11 pi over 4. Right, so whenever you multiply something pi over 8 by 2, it just becomes the same something pi over 4. So 2 times 11 pi over 8 is 11 pi over 4. So that's what's going in right there. And then it's going to be the same process as every time. 11 pi over 8, that's in quadrant 3, right? Because it's a little bigger than pi, but it's definitely not as much as 1.5 pi. So it's going to be negative. So we're going to get negative square root of 1 something root 2 over 2, all over 2. But the question here, is it positive or negative? Well, what quadrant is 11 pi over 4 in? So here's how I do it. If I'm not, well, I mean, there's a couple ways you can do it. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is just pi. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is just 2 pi. 9 pi over 4, 10 pi over 4, 11 pi over 4. Or you could break it up, right? You could say 11 pi over 4 is 8 pi over 4, which is 1 full revolution plus 3 pi over 4 again. And the 3 pi over 4 ends us up back in quadrant 2. So cosine of 11 pi over 4, if the angle 11 pi over 4 is in quadrant 2, should be negative root 2 over 2. So it's going to change it from plus cosine of 11 pi over 4 to plus negative, which I'm just writing negative. And then it's the same last couple steps, which I know we're out of time, so I'll just show you real quick. Multiply by 2 over 2. Inside, we get, whoops, yep, there we go. Well, come on, phone. You're killing me, phone. Sorry. We get negative square root of, distribute the 2, 2 minus root 2 all over 4, and then the square root of 4 is just 2, so it's 2 not in the radical on the bottom, and negative root 2 minus root 2, all on top. All right, that is some examples of the half angle formula.